Guys, do you know every smartphone and camera have an autofocus feature while recording a video? Where in this tutorial you'll be able to make a complete autofocus feature using geometry nodes without adding any manual animation about the depth of field. So let's get started. I'm working with Blender version 4.1.1 and this is a simple scene where I have, as you can see, a cube, a sphere and a background with a little shading on them. We have a camera and we have a collection of objects that we are going to use as the interacting objects for our autofocus feature. So in this case, if I press 0, as you can see, we have the depth of field in the center of the camera. And if I go in the properties of the camera settings, as you can see, I have the focus distance. But if I change the rotation of this camera, I need to animate the depth of field manually or animate an empty object to change the focus on this cube while the animation of the camera. I want to avoid this. I want a system that can let me auto change the focus distance related to the position of an empty, looking the point of view of the camera. For this reason, I'm going to create a group node with 4 methods that you can see in the modern professional camera or maybe used in your smartphone. So let's make the setup for this group node, and to do this we are going to create an object with one vertex. We are going to add a geometry nodes on this vertex, control the point of view of the camera and project this vertex on this collection of objects to find the correct position on the geometry, so the correct focus distance we need to have in this depth of field. But because we can't link directly this focus distance with the right button using a driver in an easy way, I think it's not possible yet. Even I tried to use the copy full data path from an attribute exported from a geometry node, we can use another technique. So we can make an empty like this. We can make a shape like a simple plane. Shift Z to see the wireframe, go to the edit mode, select one to select all the vertices of this mesh, press M to merge at center. In this way I can go out from this mode, select my empty as the object of the focus I need to use in the camera properties. We can rename it in focus, rename the plane as the autofocus system. I can select the empty, press Ctrl to select the autofocus system, press Tab to enter in the edit mode of the active selected objects, and selecting this vertex I can press Ctrl P to make vertex parent, so to parent the empty object on this single vertex. In this way we are going to move this vertex in the space, allowing the empty object follow this vertex. And I can prove you, if I go in the edit mode of this auto focus and press G to move the vertex, you can see the empty will follow this vertex. Now in this autofocus system we are going to go in the modifier, add a new geometry nodes and create new. If you don't see the tab in the top part of this interface, you can go to the plus general and click the geometry node. Now I am here, and because we are going to use 4 methods to create single point, multiple points, a grid for making the average position to move the empty object, like the modern professional cameras, we can start using a single point, so F3, and we can add points. We can delete this link from the group input and group the output. And what we can do is to add in our geometry input a new object. There is our camera we want to use. In this case, we can rename it in camera. We can add a collection of objects we want to use for the interactions. I can rename it in objects, and in the modifier we can select the camera and the objects for the focus. First of all, we need to change the position, and so use the transform geometry node to position this point where in the location of the camera, and we can link this output in the group output here, and you can see the position of this point here, and make the same operation with the rotation. So in this case you can see the rotation because we have the position of the point in the 0, 0 and 0, so we don't have a delta shifting, an offset from the origin point, but if I press -1 on the Z, as you can see, the correct alignment on the Z, local Z axis of this point, and this is very important because if I take the camera and change the rotation, I need the point follow this camera rotation. For this, we can use the simple offset of the point from the original point in the space. And as you can see, if I increase or decrease this, I can move my point related to the position of the camera. If I want to move in another axis, I can use the other axis. For this tutorial, we are going to use this little translation. Why? Because the idea is to take the vector of the pointing of the camera, so this direction here, and project this point somewhere on our geometries of our scene. And to do this, we must shift a little bit this point from the location of the camera. Otherwise, I can have a little piece of vector for the direction line I want to use. Okay, so we can set -1, a little number. I suggest you to select the relative and not original, but in a camera object you can't move the origin point from the center of the camera, so it will follow always the object, but for security reason, check the relative. Now, to project this point on our surface, we are going to use a raycast node. So press F3, raycast node. So the target points are what? Are the objects in our collection. So this object focus collection. And for this reason, we can add a group input, take the collection of this object, get the information related to this. We can leave these separate children off because we are going to take all these objects as one single object. And because we have from these output instances and not mesh, we need to realize the instances in mesh, because otherwise the raycast can't work properly because it needs a mesh. So we can link this geometry in the raycast node as the target for the projection. And for the source position, to project our point, we can take the location of our camera. So we can create a projection from this location along the direction of this vector through the objects of our collection. And along this vector direction means that we need to take the position of this point, subtract the position of the location of the camera to take this piece of vector to get the correct direction. So to do this, we can use a sample index, link this geometry, so the geometry of our point, the single point, and what we need is the position vector based by the index of our point. Why I'm not using 0 in this case? Because next we are going to make multiple points and not only one, so I need to use the same method inside the workflow, and for this reason I'm going to use the index. Next, we need to subtract from this position what? The location of our camera, because this is the position of the point, this is the position of the camera, and imagine you have the vector of the position of the point and the vector of the position of the camera, and you need to calculate this delta vector, so the correct trajectory. And to do this, we need to subtract from the position of the point the position of the camera. In this way, I can link this to the ray direction, and to calculate the correct ray length of this raycast node, we can calculate the maximum distance between all the points of our collection and the point of the camera, and multiply this value by a little factor to have more length and be sure to have a maximum sphere of area in which we want to project our vector on our surfaces. So to do this, we can link these in a attribute statistic and take the vector of what? Of the position of each point of these surfaces, subtract what? The position of our camera, okay, so the location, to calculate the distance from this object, like this. We can link this into the vector of attribute statistic, and from this we can take the maximum distance and calculate the length. We can multiply this maximum length by a coefficient like 1.5 to increase by half this length, and link this result in the ray length. In this way, we can ensure the correct projection inside a maximum sphere of length. depending on the objects inside our collection. Now we can easily set the position of our point. Where is the hit position of our raycast node? And as you can see here, the point now is here in this point, but if I take this camera and rotate a little bit on the Z, you can see the correct shifting position of the vertex of the point on the surface of the cube. So to continue work inside my geometry nodes without losing this part selecting the camera, I'm going to select these and press this pin icon. In this way I can select the camera without losing this part of the interface, and I can interact with this, moving this position where I want. And as you can see, we have the correct position of the point inside our geometry, so the projection works. So we can select all these 3 nodes, press Ctrl J, F2, move points in start position. We can select this node, press Ctrl H, press H on these, press H on these, and press H on this node. Now, before making the frame for these nodes, we need another thing. So if I take this camera and rotate in a point where the points cannot be projected, where is the depth of field? Okay, I cannot set an infinite depth of field value. So instead of having this problem, we can add inside our geometry nodes a default focus distance that we can use if we don't have any heating. So we can go here and add another input and name it default distance, and this is a float number, subtype a distance from 0, and we can set a default value of 10 unit measure, set the single value. In this way I can select the autofocus system, and inside this geometry node we can set 10, for example. In this way, here inside the workflow, we can move the set position a little bit. So inside our workflow, we can use this is heat in a switch, and in this way we can select a vector, and if we have a heating, we can use the heat position to move the point where we want. Otherwise, instead of using this false vector, we can use the actual position of our point, but in this case we set, as you can see here near the camera, the point in a -1 direction on the z-axis. If I go here in the native node of the points, so this offset here, and we don't want to use this offset, but instead of using -1, we want to use minus the default distance set here. In this way we can maintain the same position of the point if we don't have any heating between the point and the objects of the collection. So to do this, we need to go here and move it a little bit, and go in the native point here, add a group input node, link this distance on a multiply math operation, multiplying it by -1, because we need to move the point in a negative direction, as you can see here. Otherwise we would have the point here in this position. Next, we are going to use a combine x, y, z to link only the z direction, as you can see in this case, and link the vector here in the position. In this way you can see the correct depth of field value if we don't hit the surfaces, and if I decrease the default, we can increase or decrease the default value. Now we can move this a little bit because we are going to use the same effect also for the other methods of autofocusing. Now we can select all these nodes, press Ctrl J, F2, projects, points on meshes. Now we need to calculate the correct focus distance. So to calculate this distance, we need to calculate the distance between this projected point on the surfaces, subtracting the point of the location of the camera, and get this distance. So now we are going to calculate the focus distance, and for this we can use the position of this point, and next we are going to use the position of multiple points and not a single point, subtracting the location of the camera and getting the average position of all these points, getting the correct and precise focus distance. To make this, we need to link this in an attribute statistic node, because we want the vector of what? The vector of the position of each point projected already projected on our surface, subtracting the location of our camera, and for this we can add another time the group input, and from this camera take the object info to subtract the location of our camera, like this, select and connect this output in the attribute of our attribute statistic, and with the mean we have the average position of all these points. But keep in mind that this average of the position is related to the global origin point. So if I take and create a single new point used for the final focus distance position, link this mean in this position and link this to the geometry, as you can see we have this strange point here. But it's not a strange point because it's the previous point. As you can see, if I take these and join together with the shift control and right drag from between these two nodes, you can see this point and this point, and as you can see the vector from the origin point and this point is the same vector between the location of the camera and this point. So we need to move and shift this point, adding the location of the camera. So this vector here, and adding this vector we can shift this new point on this point position. So to do this we need to take this average and add what the location itself of the camera and link this to the position. And now I shifted this position in the correct position in the space. Why do I use this point in the final group node? Because I want to let you show or hide the points of this final focus to see it in the scene. So to do this we can add another attribute to show the points. So we can move this attribute statistic a little bit, select these nodes, Ctrl J F2, calculate the focus distance, and here we can change the show point type to boolean single value and add here a new group input and ask if we want to show or hide the points, and if we want to show them we can select these, otherwise no geometry. We can select all these nodes, Ctrl J F2, show depth of field points. Now what we can do is to move the vertex of the autofocus system, so the first vertex we made inside our geometry, inside our mesh, where in the position calculated from this zone. So the same we connected here in this point. So for this reason I can add a group input where this geometry is the native geometry we have in the scene, on which the empty is parented, is the child, and from this we can set the position of this vertex where in the position of this same object and link these where in the join geometry to add, if we want, the result of these show depth of field points in the final group node. And as you can see we have now the empty here in the same position calculated from this workflow, and if I take the camera and move a little bit in the space, as you can see we have the correct projection and shifting of the empty in the correct trajectory of this projection. If I press Shift Z to see it in the 3D space, you can see the empty here, and if I move a little bit the camera, you can see the movement and the shifting of the empty on our surfaces, like this, okay, as you can see on the plane, on the background, on the cube, and on the sphere. And now if I press 0, we can set the depth of field of our camera, selecting the camera, going in the properties of the camera, enabling the depth of field, and selecting the empty we have here, the focus. And as you can see, we have the correct focus distance set, and if we move the camera from the sphere to the cube, we have the instant changing of the depth of field based by the position of the empty on our surfaces. But as you can see, we have a very instant changing of the focus distance. In a real world, it's impossible to do it. So every technology, every device has a minimum latency of the changing of these focus distance. So if you want to have a smoothness, we are going to make this effect soon. But before of this, we are going to make the other methods to create the correct average points for our setup, because the single point is one of the possible methods we can choose. So to do this, we can add here a menu switch. We can duplicate with a Shift D the group input another time and link this menu here, rename it the menu in method, move it a little bit up, select the menu switch node, go in the node section and rename it in single point, change the B in the circle, add another one for the grid method and a fourth method for multiple points. In the group, we are going to select this method and select the default single point as a single value. In this way, I can select the autofocus, go in the modifier and see the menu here. And we can link directly the point, the single point here in this result, and link this output inside the next part of the workflow. We can select this point, press Ctrl J F2, single point method. The next is the circle, so we can create a curve circle. And for this reason, I'm going to add a panel for this method. So we can create with plus a panel and rename it in circle node and connect from this node the resolution in the group input and the radius of this circle and move these value attributes inside the circle panel. We can set a default value of 3 and a minimum of 3 as a single value, the radius itself a default of 1, minimum from 0, perfect, and it's a single value. Also in this case we need to have points. In this way the rest of the workflow can work properly. For this reason I will convert the curve to a mesh. I could use the curve to points, but in this way I will need to link this in a domain size to link the correct point count here in the count of this curve to point. So you can use this technique and link this to the circle, or you can use this curve to mesh and the mesh to points. I don't know, with few numbers the result of the timing is very similar, so I'm going to use this technique for this time. And now I can link the point here in the circle. So as you can see, if I press 0 and press Shift Z, we can see this circle. If we set for resolution, for example, and show points to see the points of our system, and selecting the method of circle. But as you can see, we have the point here and not on our surfaces because we didn't translate the position of this curve circle as we did for the single point method. So as you can see, we have the correct position here and we need to use the same operation also in this case. So we need to link this in a transform geometry and move these in the same position of the single point, like this. Next we are going to create the curve to mesh, etc. And as you can see, we have this correct projection. I don't know if you see it, but 3 of the 4 points are projected on the cube and 1 on the sphere. And as you can see, we have the average position here of the point near the 3 points, because these have a higher weight on the average position of all these 4 points. Okay, for this reason the point is near these 3 points instead of the middle position of all these 4 points. And as you can see, if I decrease the radius of these points and take this camera and rotate a little bit, I can have all these 4 points on the cube. Now we need to solve a little issue, that is this. As you can see, if I take this radius and increase this radius from the perspective of the camera, as you can see here, we have the correct radius, but if I change the default distance, we have a distortion of the radius of our circle. Why this? Because there is a relationship between the default distance used here for the translation on the z-axis of these 4 points from the camera and the radius of the circle. So if I press Shift Ctrl and click on this transform geometry, so the move points in the start position, we have this situation. I can increase a little bit the points to see the result. And if I increase or decrease the default distance, you can see the radius it's the same, but from the perspective of the camera, we have an increasing of the scale of the circle because we are projecting these points from the location of the camera. So imagine a line projected from the location of the camera through each of these points on the surfaces, and for this reason I need to rescale each time the radius of the circle based by the distance between the circle or the default distance and the location of the camera to have the same projected line directions even if I change the default distance in this attribute. So as you can see, if I press 0 to see from the camera the circle, if I decrease the default distance, I'm increasing the amount of projection line, so the angle of the projection line far away, and I need to maintain the same line of the direction for each point. So to do this, we can easily multiply what? The radius set for this circle time this default distance. So if we have 1 meter and I have this radius that I can decrease a little bit to see it from the camera, like this, for example, and if I increase like these two, as you can see, we have the half of the scale of the circle, and for this reason, if I increase the default distance, I need to increase twice the radius to maintain the same scale of the points from the point of view of the camera. So for this reason, we can easily take this radius and multiply by what? By the default distance itself, and next link this to the radius. In this way, I can decrease the radius, as you can see here, and if I increase or decrease the distance from the point of view of the camera, you can't see any changes for the scale of the points. But if I exit from the point of view of the camera and increase or decrease the distance, the default distance, you can see the changing of the scale of the radius that are at the same time the position of the points on the projection lines, as you can imagine, okay, from the location of the camera through the objects of my collection. In this way, I have a correct relationship between these two data. But it's not finished because I want to allow you to manipulate not only the count of this circle but also the rotation of this circle. So imagine you want to have 4 vertices like this or 6, but you want to rotate a little bit from the point of view. So we need to add here in this group node another input attribute like the rotation, and we can set here not degrees but a value from 0 and 1. We can remap from 0 to 2 multiply pi, so 360 degrees, so the entire round. And for this reason I can set here a minimum of 0 and a maximum value of 1, set single value, and we can take this rotation, go inside a map range, and from 0 to 1 I want to make a round from 0 to what? 2 multiplied by pi, and next link this result to what? To a combine XYZ on the Z direction, because we shifted the circle on the local Z direction, so from the same axis we need to rotate the circle, and in this way I can link these to the rotation. And now if I increase these, you can see the correct rotation of my points. Now, to have more weight on the center position of my circle for my focus, I'm going to link not directly the points of this circle inside the circle, but I will join the circle with the single centered point and next link these to the circle. Why? Because I want to have much weight in this center for the average. So for this reason I added the previous method of a single point with the circle method. Some cameras doesn't use this technique, some cameras yes, so choose the technique you need in your case. If you want or not, give a higher weight using the single point, also in the circle method. Now I can select this group input and press Shift D to link the rotation, the radius, the resolution and the default distance here to have this layout. Now we can select all these nodes, press Ctrl J F2, circle method. Now we are going to add the third method, the grid, and for this we can add a simple grid, transform on the z-axis as before, this grid from the origin point, where here in this point on the z-axis based by the default distance, and we can link directly this output in the translation socket. We don't need any rotation in this case, but we need to export this size X, size Y, vertices X and vertices Y to customize our grid. And to do this we can add another panel inside our group node for the grid, add a group input another time and drag the size X, size Y, vertex X and vertex Y. We can take all these attributes and move them inside the grid panel, and for the same reason described for the circle, we want to maintain the relationship between the default distance and the size of the grid, otherwise we would have the same behavior while increasing or decreasing the default distance here. So for the same reason I'm going to take the X and multiply by the default distance to have the same relationship, a proportional relationship. Press H and Alt S to switch these two sockets, press Shift D to duplicate the multiply node, link the default distance, but in this case the Y, and link this to the size of the Y. From these we can manipulate this mesh to points like this. Also in this case I want to use a join geometry to join the single point method and link the result in the grid switch menu. We can select all these nodes, press Ctrl J F2, grid method like this. We can press Ctrl H to this node to have a better layout. And next, the last multiple points that are the sum of all these three techniques. So we can take these geometry nodes between the first, the single point and the grid method, press Shift D another time and link this output to add what the circle method and make all together and link these to the multiple points. In this way we have the four methods. I click the grid, I have the grid. I need to decrease a little bit the size like 0.1, 0.1 and make, for example, only 2 and 2 vertices, and from the perspective of the camera I have this situation. The show points doesn't work. Why? Because I'm using the viewer here in this point of the workflow, but I can drop it with Ctrl X, and in this way I can hide or show the points. Keep in mind, if I disable these show points, this orange point is not one of the points used with these methods, but is the vertex of the mesh, the original mesh, in the correct final position, set here in the final set position where the empty is located. Okay, now if you want to test these, I can set 0, press Shift Z to see the difference, take the camera and move a little bit from the sphere to the background, and we can see the shifting of the point of the position of the empty. Why? Because while I'm moving these, we have lots of points. If I show the points, we have some points here, other in the background, and as you can see, the final position of the focus distance is in the average point of these points here. You could say, but this point is not in the center of the camera point of view. Yes, but I decided to maintain this technique. And if I take the camera and move it a little bit on my sphere, as you can see the correct shifting of the empty. And if I move these on the cube, the same result. Now I can select and change these to multiple points if I want to have a multiple point distributed, and increase the resolution of my circle and increase, for example, the radius to have multiple points distributed on the space. And as you can see in this case, keep in mind this particular position of this empty, because multiple points here, so the weight is higher here, but we have also 2 points in this position, and the weight of this point change the position of the final empty object. So keep in mind this. Maybe you need to take this circle and decrease a little bit to make these points inside the cube, okay, like this. And as you can see now, the empty is in a better position inside your scene. A last thing to do that I described before, if I change for a moment the autofocus system from multiple points to single point and select the camera moving these from the cube to the sphere, you can see the instant changing of the focus distance. And because in the real world it's impossible to do, but there is always a limit for the present of a latency, you can adjust this latency from 0 to a value that you want. For example, when you have two people that are talking together and the camera pass from one character to another character, and you want to smoothly change the focus distance from one to another. And to do this, we can go here, and before to set the position of our single vertex of the original mesh of our autofocus system, we can add a simulation zone where we can use the actual and current final position of the empty inside the node of the simulation, using this as the starting position for the empty, and this will be used only one time in the entire animation. Next, the system will reuse the same value here for the next looping on the next frames, giving the output from this simulation output. And for this reason, I'm going to move this a little bit, this out, and I'm going to use this output for the position of my empty. Why? Because I want to use a mix node from what? From the current and desired position, the final desired position of my focus distance, and a proportional part of the previous position I stored before. So in this way, with this little node, we can have an initial value of n, and in the next frame we are going to use the next new value mixed with the previous value, and using this factor we can control the effort, the affected weight between the previous value stored in the previous frame and the new one, and this output will be used in the next loop, and so on until the end of the animation. And controlling this factor, we can have the smoothness of the shifting position from the previous to the final position. Now we can link from this geometry input the geometry inside our simulation zone, because here we have the vertex we want to use to set the new position in the space, link these to the set position, and maintain this join geometry to see the effect of the points if we want to have it. Now we need a smoothness factor where inside our geometry input like this, and we can control the smoothness. This is a factor, a float value from 0 to 1, and it's a single value. So we can press Ctrl H, and before going inside the mix we need a map range, because if I want more smooth, we want to use here in the factor a low value, not a higher value. So if I have 0.1, I want to maintain a higher weight from the previous position of the empty, okay, with a minimum part of the B value, so the final position I want to set on the empty. So in this way I will need more frames to set the position of the empty on the final position. And for this reason, I will map these in a map range, setting here from 0 to 1 to 1 and 0, and linking this result in the factor. Now, if I go to the first frame, you can see the actual position of the frame, because we set here in the output, we can rename this output in final position, like this. And as you can see, in the first frame, we have the final position used for the same mixing of the same value, used for the position of the empty. And now I can increase the smoothness. I want more frames to have the animation of the focus distance. And now if I take my camera and press play to the animation, I can move these on the cube, and as you can see, a smoothed change of the focus distance as a real device. Okay, and if I take this auto smooth and increase again 0.95, if I take the camera and move it a little bit, as you can see, the movement of my empty is lower, and you can control this smoothness as you need without animating anything or add any keyframes. I would suggest you to move this value to 0.3 or 0.2 to use a little number of frames. We can select all these nodes, press Ctrl J, F2, smooth, focus. You can select whatever group input you need, go to the select menu, select the group type, press twice Ctrl H to collapse all the unused socket, save the project, rename the geometry node in autofocus, toggle the pin we have here, right button on the autofocus, mark as asset, save the file, and if you have the file in your path of assets of Blender, you will be able to reuse the autofocus system in the asset browser. Or if you want to use and add in a single project, you can use the file, link or append, double click to this file you can download always from my Gumroad page, double click on the objects folder and double click on the object autofocus system. In this way, the system will add not only the mesh of the autofocus system, but also the focus empty and the geometry node you need for this setup. You only need to select your camera in your scene, go to the camera properties, enable the depth of field and select the empty used for the focus, and select the autofocus system, go to the modifier and select your camera and collection of objects, setting all the other parameters as you need. A little tip about the selecting of the camera: if you don't want to select all the time the camera inside the autofocus but use the active camera of your scene, you can go here and instead of using a camera object in the group input, you can always use with the F3 the active camera object and link this object into the object info node. Keep in mind you need to use this technique also in the other part of the workflow. Instead of using the group input socket, you can at that point delete from the group node. And that's it. Thank you guys for watching this video. I hope you learned something from it. Thank you always for your support. You can download this project from my Gumroad page as always. If you liked my work, please subscribe to my channel and don't forget to set the bell icon to get all the notification of my new videos. See you to the next tutorial. Bye!